Good morning, sir.
So,
Yes.
Good morning. Morning. Okay. So, last few classes we discussed about authentication. What are the factors of authentication? Like what you know, what you have, and what you are. Based on that, we can classify it as single factor authentication and multi-factor authentication. Students, whatever I told you have to make notes of it, points. Okay. So these things we discussed, and we also discussed one-way authentication and two-way authentication. So a person whose identity needs to be proved is called an entity. You can say an entity whose identity needs to be proved. We call it as claimant. An identity, like an entity that tries to prove the identity, we call it as verifier. Okay. After that, we discussed about the approaches of authentication, the two major approaches, that is password based authentication and cryptography based authentication. Under password based authentication, we discussed about fixed passwords and one time passwords. Under fixed passwords, we discovered that there are a lot of loopholes or vulnerabilities with fixed passwords, like eavesdropping, sniffing, password guessing, unauthorized access to password files. All these are the issues with fixed passwords. So we have something called as fixed password hashing and fixed password salting to overcome these problems. And then we discussed something about one-time password, where we didn't find any vulnerabilities much as in fixed passwords. Okay. Then we moved to cryptography based authentication. Under that, we discussed about authentication based on symmetric key without a trusted third party. Then authentication based on symmetric key with a trusted third party. It is also called as Needham-Schroeder symmetric key authentication. Then we discussed about authentication based on public key. So that is Needham-Schroeder public key authentication protocol. So whatever the diagrams I have given you, those are important. I have asked you to write it down. I hope you have written it. So based on that, stepwise you can write, even without the diagram also you can write if I ask you to write it with respect to steps. Okay. So that's what we discussed in the previous classes. And a few more things before going into the applications of authentication. Would like to discuss few more things about authentication, the other techniques. So let me share the slide. So hope this is visible to you, students. Can you see the slides?
yes,
Yes.
Okay. Okay. So some terminologies and requirements. I think this slide I had already discussed, but let me again go through this. What is the mechanism or service used to verify the integrity of a message by message authentication? Okay, and assures that the data received are exactly as sent by, and that is supposed to identify one of the sender is valid also. Basically, when you are proving authentication, you will prove integrity also. Procedure to verify the received messages come from alleged sources and not been altered. Also verifies sequencing and timelines by authentication. Okay. So what you call as digital signature authentication technique, that also includes measures to counter repudiation by the source. Okay. So let us see what is digital signature, and before that, some more points. So what is an authenticator? A value to be used to authenticate a message. What is authenticity? Used to verify the message. Authenticity is used to verify the message, and authenticator is a value to be used to authenticate a message. So there are many procedures to produce an authenticator. So the three types where you can produce an authenticator is using hash function, message encryption, and message authentication code. Okay, hash function, message encryption, and message authentication code. Let us see what are these. Uh, what do you mean by hash function, message encryption, or message authentication code? Okay. Message authentication code involves the use of secret key. Let us first we'll go with message authentication code. Okay, involves the use of secret key to generate a small fixed size block of data known as cryptographic checksum or MAC, that is appended to the message. Okay, involves the use of secret key. So you have the data. For that data, you will add, using the key, you will generate a cryptographic checksum. Is that clear? That is called as message authentication code. That is actually appended with the message. You can see here what is MAC. So you have a key, you have M. What is M? Input message. What is C? MAC function. And what is K? Shared secret key. Is that clear? Message authentication, MAC is message authentication code. MAC is equal to C of K comma M, where is C is MAC function. That means an algorithm. How you are going to generate it? You need to have a function for it, and using that you will generate it. For that MAC function, what is the input? Input is a shared key and the input message. Is that clear? So when you give the input, shared key and input message itself to a message authentication function, you will generate a message authentication code. Is that clear, students? So that's how you generate a MAC. So what is hash function then? Variation of MAC is one-way hash function. Is that clear? Variation on the MAC is one-way hash function. So as with MAC, a hash function concept accepts a variable size message M as input and produces a fixed size output referred as a message or hash code. Is that clear? What you have to consider here is, in hash function you are not going to use any secret key, only you are going to use the message. Whereas in message authentication code you will be using the message and also a key, whereas in hash function you are just going to use the message. Is that clear? So what you are going to do there, you have a hash function. Is that clear? Not message authentication function, that is different. You have a hash function here, and for the hash function you are going to give the input, that input is the actual message itself, and with that you are going to generate a hash code. Is that clear? You can see a hash value h is generated. A hash value h is generated by a function h of the form, where m is variable length message, h of m is fixed length hash value. Is that clear? So for the hash function you are going to give message as the input, and from that you are going to generate a hash value. Is that clear? We call it as hash function. Unlike MAC, hash code does not use a key. That's what I told you, but is a function only of the input message. Hash code is also referred as message digest or hash value. Keep this in mind, students. Hash code is also referred as message digest or hash value. Am I clear? Shall we go to the next point?
Yes.
The hash code is a function of all the bits of the message and provides an error detection capability. How it provides an error detection capability? A change in any bit of the message results in a different hash code. That means, say for example, you have a message. Let me draw it here. Hope this is visible to you, students. Okay, so you have A, and whatever the diagram I write, it's better if you also copy it, students. I have a user A and I have a user B. User A wants to send the data to B. What A will do, A have a message with it. Is that clear? And that message is given to a hash function. Is that clear? So which will generate a hash code of A. Let me draw it like this. Hash code of A, and this is sent to B. Is that clear? That is just H of A. Hash code of A is sent to B. Is that clear? And in between, plus hash code of A plus message is sent to B. Okay. And what B will do? B have received what? B have message now. Again, B will feed this message into a hash function, again the same hash function which A has used. So it will get a hash code B. Okay, it will get a hash code B, and when hash code of A is equal to hash code of B, that means both the message what A has sent is not altered. Okay, you are proving the identity here. Is that clear, students? We are proving the identity here by comparing the hash codes of both in A and B. What A did, A have a message that fed that message into a hash function, and it generated a hash code called H of A. And then that H of A plus M, that is message, is sent to B. What B did, B have a message which is received from A, and that is feeding that message into the hash function. The same hash function is used which A has used, and B will get a hash code called H of B, and B will compare H of A and H of B. B has received H of A also. When these two are same, that means integrity of the data is proved. That means there is no change in the message. Is that if there is any change in the message, this hash code of B will not match with hash code of A. Is that clear? As simple as that. This proves the integrity of the message. Is it clear, students? Is it clear to you how to prove the integrity of the message?
Yes.
Okay. So that's what it says here. The hash code is a function of all the bits of a message and provides an error detection capability. To change A change to any bit or bits in the message results in a change to the hash code. When there is a change in the hash code, obviously message what you have received is not the actual message sent by the sender. Is that clear? Integrity is proved here, or integrity is questioned there. Basic uses of hash function. H. Encrypt. What you are encrypting? The message and appended hash code using symmetric encryption. Is that clear? That means symmetric key encryption, asymmetric key encryption. Keep this in mind. Symmetric key means both sender and receiver is using the same key to encrypt and decrypt the data. Asymmetric key encryption means you are not using the same keys. You might be using different keys like public and private key pair. I don't have to explain about the public and private key pair to you now because you already know it. Okay. So first thing is you have the message, append it with a hash code, encrypt it using the symmetric key and sends it to the destination. One use of hash function. Then encrypt the hash code using symmetric key encryption and concatenate it to the message. That way also you can do. Is that clear? Don't encrypt both message and hash code. Only encrypt the hash code using a symmetric key and concatenate with the message. Is that clear? Then encrypt hash code using asymmetric encryption, that means sender's private key. Is that clear? And append it to the message we call it as digital signature. Very, very important, students. How you are generating the digital signature? How you are generating the digital signature, students? Why digital signature? Digital signature is used to check whether you are getting the data from the right person or not. How do you prove it? Is that clear? So let me clear it. I want to discuss about this in more detail. So let me draw it here. I think it is visible to you, right, students, whatever I am drawing?
Yes, sir.
Okay. A, you have data, that is message. Okay. You have a data M, and you are encrypting that M. Sorry, you are giving this M to a hash function, and you call it as H of A. Okay. Now you have H of A, which will be encrypted using the private key of A. Is that clear? Private key of A, let me write it as PR, key APR, that is private key of A. From that you are encrypting the hash code. So you are sending it to B. You are sending message plus H of A encrypted using key which is a private key. Now my question is, can B decrypt this? Can anyone respond?
Yes, sir.
How B can decrypt it? With what key B can decrypt it?
Public key of A.
Public key of A, because as the name itself tells, public key, that means B can know A's public key, A can know B's public key. Is that clear, students? So what's happening when A encrypts something with its private key, for B, what B will understand upon receiving this? B has received this message plus H of A encrypted using the private key of A. So when it is encrypted using the private key of A, for B it is very sure that okay, it is encrypted using the private key of A. That means A only would have sent this message. So it is very much confirmed that I have received the message from A, which proves authentication, students. Is that clear? Which proves authentication. Am I clear, students? So what B will do? B have actual message. B will decrypt it, and B will get H of A after decrypting with the public key of A, H of A. Now authentication is proved, and to prove the identity, what it will do? It has a message. It will feed that message into a hash function. It generates H of B, and that H of B will be compared with H of A, and if both are same, that means integrity of the data is also proved and authentication of the data is also proved. Both are proved at the same time. Is that clear, students? So it should be very clear to you by this time now what is integrity and what is authentication. Authentication can be proved by using digital signature technique, and integrity can be proved by getting the hash function or hash code. Am I clear, students? If suppose A encrypts its data using the public key, will you be able to prove the authentication? Will you be able to prove the identity of A if A encrypts the hash function using its public key? Can anyone tell?
No, sir.
No. Why? Because when A encrypts something using its public key, nobody can decrypt it, and anybody can use A's public key to encrypt any data. Is that clear? Say for example, uses A's public key to encrypt it. Only A can decrypt it. Nobody can decrypt it. Is that clear? That we will use for confidentiality. I will come back to that later. Okay. So now authentication and confidentiality, I hope it is proved like you have understood how to prove the authentication and integrity, not confidentiality, sorry, authentication and integrity. Am I clear, students, with this? Is this point clear to you with respect to authentication and integrity and how to prove it?
Yes, sir.
Okay.
Sir,
Fourth, yeah,
but if it has to be decrypted using public key of a, anyone else also can decrypt it, no, sir?
anyone else can decrypt it. We are not concerned about the confidentiality here. My point is somebody should get to know, whoever receives it should get to know I have sent it. That's all. And whatever I have sent, they have received the same thing.
Okay, sir.
Here we are proving only the integrity and authentication. We are not worried about the confidentiality. I'm not speaking about confidentiality here.
Okay, sir.
Clear, right?
Yes, sir.
Okay. And fourth point, encrypt the encrypted hash code plus message using a symmetric secret key. Okay. Encrypted hash code plus message. So what is encrypted hash code? You are using a key which is private key of A. Is that clear? Hash code of A. This is what you have. This is encrypted hash code plus you have message. Generally we used to send these two. If we send these two, it is very much proved that authentication and integrity. Now if I encrypt these two using a session key, that is symmetric key, the fourth point, if you see, encrypted hash code plus message using a symmetric secret key. Is that clear? Symmetric means both sending and receiver uses the same secret key. So what you are trying to prove here, student, in this case? Can anyone tell me?
Confidentiality, sir.
Yes, you are trying to prove the confidentiality also here. Why? Because you are encrypting the message. You can see here nowhere previously we tried to encrypt the message. Here we are trying to encrypt the message also. Is that clear? So when we encrypt the message using a session key or a symmetry key, both. So upon receiving this, receiver what will do upon receiving this? Receiver will first decrypt it using the same session key because it is symmetric key. We are not worried now how this symmetric key is exchanged between two parties. We know that both have the key. Is that clear? That might be received from a trusted third party or whoever it is. Okay, we know that both the parties have the symmetric key. So when this is received, first what B will do, B will decrypt it using the same key. When B decrypts it, it will receive the message and it will receive the encrypted hash code. When that will prove confidentiality. And now this encrypted hash code will be decrypted using the public key of A because it is encrypted using the private key of A. So when it is decrypted using the public key of A, the receiver has both. The receiver have H of A plus message now. Is that clear? So now what happened when you are trying to use the public key of someone to decrypt it? Obviously it is from the right person. So you will now first initially when you decrypt this, you are proving confidentiality. When you decrypt this, you are proving integrity. Is that clear? Sorry, you are proving authentication. You are received from the right person. Now what you have to do, you have to get the, what B have to do, B have to get the hash code of M. Is that clear? Message. So when it gets the hash code, that will be H of B, and this H of B and H of A will be compared, and when both are compared, if they are same, then integrity is also proved. So the three major factors of security: authentication, integrity, and confidentiality, all the three are proved here. If you can prove all these three, your data what you have sent is, we can say, 95 to 98% secure. We cannot say it is 100% secure, students. Is that clear? Because whatever you have encrypted the message, integrity and authentication, you can 100% say it is proved. Whereas confidentiality, you cannot say 100% proved, because somebody can in between use the same key to decrypt your message. That can be done. Is that clear? But to some extent, you are definitely securing your data. Am I clear, students, to about the three factors? Is it clear to you?
Yes, sir.
Okay. So use a hash function, but no encryption for message authentication. Assume that the two parties share a common secret value S. So the same thing, whatever I have discussed with diagrams, it is written over here. But if you understand this, it is very easy to answer any question. Is that clear? You should know this. Yeah, there are a few diagrams here. You can see the first one, A, B, C, A. Basically, here, one second. Okay. Yeah, you have a message. You are giving that message into the hash function, and that h of a and say h of m and the message, you are encrypting it using a key. You can see here, you are encrypting using a key. You can see it is encrypted using a key. What is there in it? Message plus hash code. You are giving it to the destination. What destination do? Destination first, it will decrypt it, and once it is decrypted, it receives the message and it creates a hash code of that message, and whatever the message it received, it will compare it. Is that clear? The diagrammatic representation, I have written the diagrammatic representation, but this is another way. Is that clear? I have written the timing diagram. I had given you the timing diagram. Now you have the message, uh, uh, get the hash code of the message, and that hash code of the message is encrypted, and that is encrypted to that is concatenated with the message. The same thing, whatever the points we discussed, it is given in diagrammatic representation here. Is it clear, students? And then in the receiver side, what happens? It will receive the message which is encrypted. So basically it will decrypt it, and then uh, finally after decrypting, it will compare it. So where you have to use what key, you should be in a position to know. Is that clear? Just a second. Okay, please note down, students, when in general terms, if key S E is written, this is called, please note down on this, it is a session key. Is that clear? It is called as a session key. Is it clear? So then key S minus, if I write here. So this is a term used for sender's private key. Sender's private key. Is that clear? Sender can be A, B, whoever it is. Key sender private means it is minus. Is that clear, students? And to the key pair of this will be sender's public key. If you use plus, it is public key. If you use minus, it is private key. Please make note of these things. Am I clear? So I think this textbook, soft copy of the textbook, what I am referring is not there in the internet. What I'll do is I will scan some of the pages which are very important for you, and I will share it with you. Okay, you can. There are good diagrams in that which will help you to understand more clearly.
Sir, can you repeat the plus minus?
Minus is private key and plus is public key. This is the network jargon of representing senders public and private key. Key S hyphen minus means senders private key. Key S plus means senders public key. Key R plus key R minus means receivers public key and receivers private key.
Yes, sir. Thank you.
So hope this is clear to you. Let me go to the next slide. Hash function requirements and security used to generate fixed length fingerprints for arbitrarily large messages. H of M calculation should be easy and fast. Indeed, they are even faster than symmetric ciphers. Is that clear? So some requirements and security for hash function. How do you generate hash function? It is used to generate fixed length fingerprints of arbitrarily large messages. H of M calculation should be easy and fast. You should have functions which can generate faster hash functions, and it should be easy to do. Indeed, they are even faster than symmetric ciphers. Hash function should be one-way function, pre-image resistant. That means you cannot send it back. One way. It's used for only for that session, that too one way. Given H, it is computationally infeasible to find X such that H is equal to H of X. Is that clear? If we give you a hash function without a message, from hash function you will not be in a position to determine the message. Is that clear? Therefore, as I said you, message, and this message is fed into a hash function, and this will generate a hash code. Is that clear? So if I give you H and if I don't give you M, with the help of H, you will not be able to generate, or you will not be able to see message. Is that clear? Not possible. But the other way is possible. If I give you M, you can generate hash function of it. Is it clear? That's what it means. Given H, it is computationally infeasible to find X such that H is equal to H of X. Complexity of finding X out of H is 2 to the power n. Is that clear? Polynomial, you can say it is polynomial P problem, NP problem, basically NP problem. Okay.
Sir,
Yeah.
sir, sorry for the interruption, sir. Priya is asking to say like, can you make everyone attendees?
Yeah, I can do that.
She is having some trouble. Sir.
Yeah. Sorry for that. Should have done it because give me a second. Just a second, student. My net is quite slow. Okay. I have done that. Where
Thank
was
you.
it? Okay. Okay. So complexity of finding x, that means the message, out of hash function is 2 to the power n. It's a NP problem basically, students, which is we cannot say impossible, but highly difficult. Is that clear? That is what 2 to the power of n, exponential problem, or NP problem, you can say. Okay. So weak collision resistance. So given x, it is computationally infeasible to find y with h of x is equal to h of y. If you have two hash functions, and if you have x, the message, with that you cannot find what is y. That is also not possible, which is also 2 to the power n. It is not generally nobody do it, but you should know all these points. Okay, so that's about the hash function. Let us go to the next slide. Yeah, strong collision resistant. It is computationally infeasible to find any pair x comma y such that h of x is equal to h of y. The other way you can say, again, it is computationally impossible, and complexity is 2 to the power of n by 2, which is again equal to n. 2 to the power of n by 2 is also equivalent to 2 to the power n. So that's about the hash functions. Hope hash function is clear, and by this time you should be in a position to know or understand what are the major uses of hash function, which is a very very important factor in providing authentication and integrity, improving authentication and integrity of any message. Is that clear? So important hash functions are message digest phi, which is widely used. Message digest phi, it's an algorithm or hash function, you can say, which is widely used to generate hash functions for the messages. Message digest phi. So arbitrarily long input message, it will help for arbitrarily long input messages. 128 bit hash value, it generates 128 bit hash value and has been used extensively, but its importance is diminishing. Okay, because of brute force attack. Okay, but anyway, still we are using MD5 extensively, and we are expecting there will be updates for MD5 in near future. Okay, so there are some reports of attacks have been are there for MD5 hash function, but still very negligible. So the other one is SHA, secure hash algorithm 1. So it is a NIST standard. Input size of the data should be less than 2 to the power 64 bits. Hash value size will be 160 bits. The previous one, if you say, it is 128 bit hash value for MD5, and for SHA it is 160 bits. This is also widely used, students. SHA is also, SHA1 is also widely used. Hash value size is 160 bits. Brute force attacks are not so probable. 2 to the power 80 is not a bad complexity. Is that clear? Here it is 2 to the power 64. For the complexity of the brute force, like the complexity to find the hash code using the brute force attack is 2 to the power 64, which is a very big number. Okay, for MD5, and for SHA it is 2 to the power 80. The major reason here why is because hash value size differs for MD5 and SHA. For MD5 it is 128 bit, and for hash value for SHA it is 160 bits. Okay, however, NIST published FIPS 180-2 to standardize, and there are many other standards of SHA, that is SHA 256, SHA 384, and SHA 512 for computable security with AES. Is that AES is a encryption algorithm? We will see that later. What is AES? Okay, so this is about the different hash functions what we use. Two major hash functions, that is MD5 and SHA1. So which of the following is not a principle of data security? So can anyone tell? Which is not the principle of data security out of this? Data confidentiality, data integrity, data availability, and none of the above.
Data availability, sir.
Next question. Which of the following security attacks is not an active attack? Masquerade, modification of messages, denial of service, and traffic analysis. Which one is not an active security attack?
Traffic analysis.
Yes, you are right. The first answer for the first one is data availability, and second one is traffic analysis. Okay, so we'll stop here for the day, students. Some typical secure hash function we will see in the next class. Take care till then. Tomorrow itself we have a class, right? Yes, tomorrow itself we have a class. We'll discuss that in the next class. Okay. Take care till then. I'm stopping the